This video will cover the second page of notes for the topics of applications of logs and exponents. On the previous page, we talked about compound interest, and we had this particular equation for compounded interest. And at the end of the last video, we talked about what happens if we decided to compound more frequently, like every day, or every hour, or every minute. We call that compounded continuously. In this video, we're going to talk about compounded continuously. Notice that our equation for compound interest has changed. Now we have what I call APERT, where A is still equal to the amount that you will have after some time. P is the original amount of money that you put in. P stands for principal. R is the interest rate, the annual interest rate, and we're going to make sure that we write it in decimal form. So if we had 5%, we're going to use R to equal to 0.05. And then T is the time, and notice it is in years. So if they give you a problem that says what happens in 6 months, remember that's 1/2 of a year. That's all dependent because the rate is yearly. So the time has to be with years as well. So let's do a couple of examples. For the first example, let's suppose we have $1,000 that we need to deposit in an account paying 4% interest compounded continuously. And I have underlined compounded continuously because that tells me what equation we need to use, which in our case is going to be APERT, or A is equal to P times E to the RT. And we're going to put it into this account for 10 years. Our job is to find the amount in the account after 10 years if we don't touch the money without withdrawals. And then secondly, we're going to see how much interest is earned over those 10 years. So the first thing we're going to do is take a look at our equation, and we're going to plug in everything that we know. We know that we deposited $1,000. So that's going to be our initial amount here. This is the amount for P. Our rate is 4%, so we're going to write it in decimal form, so 0.04. That's what we're going to see right here for the R. And then we need to know T is how many years we keep it in that account, and we can see T is 10 years, so I can substitute it right here, and that's equal to T. Remember that E is our base, and that is a known number. So all we need to do is to put this into our calculator so that we can figure out the amount of money in the account. Remember, this amount of money includes what we started plus the interest. So let me show you how to put this in the calculator. I've highlighted what we're going to enter into the calculator. So we're going to put in 1,000. And then we need to get E, our base. There's a couple places where you can find E, so I want to show you both of those. One, you should be able to see E right on top of the division key. So in other words, I can go second and then put my division key, and we'll see little E there. Then I need to use my caret, that's the symbol on top of the division symbol, for exponents, and notice it automatically puts it up there. And then I can multiply 0.04 times 10 and get 0.4, but I'm going to show you that I can stick it in those parentheses as well here. So I'm going to put 0.04, and I'm going to close parentheses, open parentheses, and put a 10 right here. And we can see the exact same thing that we have highlighted is exactly what we have here. When I push enter, we're going to find that at the end of 10 years, you would have $1,491.82. And that's where I'm getting this value from here. Let me show you another way that you can put this into the calculator that may be a little faster. You can type in your 1,000. And notice it knows that it's going to multiply 1,000 times E to the whatever, and it's using the E to the whatever is your order of operations. It's going to solve that first, and then it's going to multiply it by 1,000. So we can also go find E to that exponent right here on top of ln. So I'm going to do second and then the ln button, and it automatically types in the E as well as ready for the exponent. Remember that ln, or the natural log, is the inverse of e to the x, and that's the reason why their inverse functions are shown one above the other. From here, I'm ready to go on ahead, and this time I'm going to go ahead and multiply 0.04 times 10 and get 0.4, and then I'm going to push enter, and we should see the same value. Let's go to part B of our problem. It states how much interest did we earn over those 10 years. Remember that A is the new amount of money in the account. It includes both the P as well as the I. In other words, P is going to be for our principal, the amount we started with, and I is the interest. So I have A is equal to P plus I. I know how much I have after 10 years. That's that $1,491.82. We know how much we started with, which was 1,000, and then we're just looking for the amount of interest. So subtract 1,000 to both sides, and that's how you'll find that I found the interest to be $491.82. Let's go to the second example. Suppose money is deposited in an account paying 3% interest per year compounded continuously. Our job is to find out how long it will take to double our money. So what we do know is that we're going to use APERT because we found the magic words that said compounded continuously. Now the next question is, how much do we put in so that we can double that money? Notice they never told us that. So you can pick whatever number you want for the principal, and you automatically know how much the total amount is because we're just going to double it. Most likely P is equal to 3 would be what I would pick, and then A is equal to 6 because we doubled it. Again, they could also ask me, how long will it take to triple it? Well, if I want to triple it, if I had P is equal to 3, then A would equal to 9 because I'm multiplying it times 3 to triple it. In this case, we're multiplying it times 2 to double it. So again, if they don't tell you how much to start with and they're going to double it, it's okay. We can pick your favorite number. Later on, we'll find out that P is equal to 1 might be your favorite number. Now that we know the value for A and P, I input those, so that's where I get my 10 is equal to 5 times E. I need R. R is my interest rate. They told me that that was 3%. Remember, we're going to put it in decimal form. That's how we got the 0.03. And then T is what we're looking for because we want to know how long it takes to double it. From here, the very first thing I need to do, so I have A is equal to PE to the RT. When you're trying to solve for something in the exponent, first thing we're going to do is isolate that exponent, so we're going to divide both sides by P. So in this case, we're going to divide both sides by 5. And that's how we're getting 10 divided by 5 is equal to 2. Here's the other hint. Remember when they talked about doubling? That's where that 2 came from. So that's the reason why it doesn't matter what number we had. If we had 6 is equal to 3e to the 0.03t, first thing we do is divide by 3. We'll see how we'll get 2 is equal to e to the 0.03t, which is the exact same thing we have already written down. So we're going to continue solving. Notice that we have 2 is equal to e to the 0.03t, and we have our exponent has our variable. We can't get the same base, so we're going to take the log of both sides. And we learned last time that if we had e as a base, then we should take the natural log of both sides. Therefore, our equation becomes the natural log of 2 is equal to the natural log of e to the 0.03t. Using the third property of logs, I'm going to put my exponent to the front, and now I have the natural log of 2 is equal to 0.03t times the natural log of e. And remind yourself that the natural log of e is equal to 1, and 1 times anything is that anything. So now we have this problem to solve. Because I want to find t, I'm going to divide both sides by 0.03, and that's how I ended up with this value over here. That t is equal to the natural log of 2 divided by 0.03. And again, if you're going to put this in a calculator, don't forget to close that parentheses before you put the division bar, and you would see that the estimated amount of time to keep your money in there is 23 years. And that concludes this video.